Hello guys, you're welcome to this lesson. In this lesson, we'll be looking at Rutherford Alpha Scattering Experiment, the famous Rutherford Alpha Scattering Experiment. So basically, after Thomson suggested his plum pudding model that the atom is a solid sphere which is positively charged, his colleague Ernest Lord Rutherford, accompanied with his students Marsden and Geiger at Manchester University, performed the famous alpha scattering experiment. So I have the diagram on the board. So for Rutherford's experiment, he used what we call the alpha particle. He used what we call the alpha particle. The alpha particle is a radiation that is emitted from a radioactive substance or an element. Is that okay? And this alpha particle, it is positively charged. It has a proton of 2 and a mass of 4. It is dense. Is that okay? So in the diagram on the board here, I have my source of alpha particle here. And then what did he do? He struck the alpha particles against a thin gold foil. Is that okay? So the blue line you see over here indicates my thin gold foil. He struck the alpha particles against the thin gold foil. That was the experiment. So Marsden and Geiger observed what is going to happen once the alpha particles strikes or bombards the thin gold foil. To their surprise, these were some observations recorded from the setup. They could observe that most of the alpha particles were passing through the gold foil, and then it was detected on the fluorescent screen detector here. So on this spot here, most of the alpha particles were just trooping in. We're just moving through the gold foil without any deflection. Is that okay? And they were just striking the fluorescent screen detector over here. Another observation was that some of the alpha particles were deflected. So once they get into contact with the thin gold foil, they could see deflections. They were deflected at angles, different angles. Is that okay? So some of the alpha particles were also deflected at angles. So I have some of the alpha particles are deflected. So the diagram here, the arrow here indicates the deflected alpha particle once they came into contact with the gold foil. And the very last observation was that a very few of the alpha particle bounced backwards. So once the alpha particles got into contact with the thin gold foil here, a very few of the alpha particles were seen deflected backwards. And then I use an arrow here. So the dotted lines here indicate the bouncing back alpha particles. So very few alpha particles bounced off the foil. Now, what is the interpretation to this observation? So Rutherford has to come in and reason to explain this basic observation. Why is it that most of the alpha particles were trooping in, were moving through the thin gold foil without any deflection? Why is it that some alpha particles were being deflected? And also, why was it that a very few alpha particles bounced backwards off the gold foil? After several reasoning, Rutherford came with the ideology that, one, the reason why most of the alpha particles were able to pass through the thin gold foil without any deflection indicates or suggested that the latter part of the gold foil atom or the gold atom is an empty space. So it is due to the large empty space of the gold atom, that is why the alpha particles were able to move through the atom without any deflection or any collision. Is that okay? So the latter part of the atom, he suggested that it is composed of empty spaces. Is that okay? And that is why the alpha particles were able to move through the gold foil here without any deflection or any collision. Is that okay? Now, the second observation which suggested that some alpha particles are deflected. What caused the deflection? So Rutherford again reasoned that since the alpha particles are positively charged particles, the alpha particles could only be deflected only if they came into contact with another positive charged particle. Because the alpha particles themselves, they are positively charged. So there will only be deflection if they come into contact with another positive charge. So Rutherford reasoned that it means that alpha particles came close to a certain positive center. That is why they were deflected. What do I mean by this statement? If I have a ball directed towards a wall, if I strike the ball straight to the ball will bounce back directly to me. Is that okay? But if the ball hits a different direction, it will deflect to a different direction. Is that okay? So the alpha particles came close to a certain positive center. That is why they were deflected at angles. And that was the cause for the deflection. So Rutherford reasoned that since the particles were deflected, deflection can only be caused if like charges come into contact. And since the alpha particles are positively charged, then it means there's a certain positive charge center somewhere that was responsible for the deflection. Is that okay? Now the last observation which brought joy when Marsden and Geiger were performing the experiment was very few alpha particles bounced off the good form. Very few alpha particles bounced off the good form. So Rutherford then also explained the point that the alpha particles came close to a certain massive positive center. The alpha particles came close to a certain massive positive center. That is why they were deflected backwards, or they bounced backwards. So in Rutherford experiments, the observations made was that most of the alpha particles were able to pass through the gold atom without any deflection. Some of the alpha particles were deflected, and a very few of the alpha particles were seen bouncing off the gold form. He came to explain each observation as in the first one, suggesting that the larger part of the gold atom was an empty space. That is why most of the alpha particles were able to pass through without any deflection. Is that okay? And then he also explained the second observation that the alpha particles, since they are positively charged, they came close to a certain positive center. That is why they were deflected at angles, or they were deflected. Is that okay? And now the last observation, which talks about a very few alpha particles bouncing backwards, suggested that the alpha particles came in direct contact with a certain massive positive center. That is why they were bouncing backwards. This was the interpretation to the observations made by the alpha scattering experiments. Then Rutherford has to reason. Rutherford reasoned that what Thomson said. Thomson talked about the plum pudding model. You see, in the plum pudding model, he described the atom as a solid sphere, which is positively charged, with electrons stacked in it. So if indeed the pudding was actually correct, then it means once the alpha particles strike the gold atom, there should be a lot of deflection, because the atom itself, Thomson suggested it to be a positively charged sphere. But that wasn't the case. So Rutherford reasoned that no, the plum pudding model is inaccurate. The plum pudding model is inaccurate. So he brought a new model of the atom. So Rutherford suggested that when you take the atom, it has a center where the mass of the atom is located, and this center is positively charged, and we call it the atomic nucleus. The atom has a center where the mass of the atom is located, and this center is positively charged. And this center we are talking about here occupies a small volume compared to the whole volume of the atom. It occupies a very small volume compared to the whole volume of the atom. And around this nucleus, we have electrons, and these electrons move around the nucleus at high speed. So Rutherford suggested a new model which can be compared to the solar system. You see, in the solar system, we have the sun, and then the planet moving or orbiting around the sun. So Rutherford described the atom to have a center, that is the nucleus, which indicates the sun, with the electrons indicating the planet that is orbiting or moving around the nucleus. That was a new model of the atom that was proposed by Ernest Lord Rutherford. After Rutherford experiment and model, he was accredited for the discovery of the atomic nucleus. That was something D.J. Thomson's experiments and model couldn't explain. Is that okay? In Rutherford's model, he said the atom has a massive center known as the nucleus, which is positively charged, and it has electrons moving around it in orbits or in shells. So I have a diagram here which indicates the model of the atom proposed by Rutherford. So the center that we're talking about, that is the nucleus. So I have here dense positively charged nucleus. So this is our nucleus, and then I have the electron that is orbiting around it. We can draw it in a very simple form. This is my nucleus, and then also I have my electrons moving around the nucleus in orbits or in shells. This was the model of the atom proposed by Rutherford. Thank you. Don't forget to subscribe to the channel. We shall meet again in our next lesson.